This is a Tektronix Type 191 constant amplitude signal generator. One of the bits of redundant test equipment we used to use at work when we used to manufacture oscilloscopes, which we don't do anymore. We haven't done for some 30 years or so. I rescued this from the scrap man. The scrap man was going to take this away with a couple of other bits of test equipment. There's nothing else I wanted, but this is, I thought, was quite interesting. It's a valve operated bit of equipment that was used to for calibrating the accuracy of the scopes that were manufactured. I've just plugged it in. I have actually had a look at this unit before, but quite a few years ago. I've plugged it in, powered it up, and it's running on the Variac, because it uses the most ridiculous connector I've ever come across. It's like a sort of like a 3-pin American plug inverted. So I plugged it in, and it seems to work really very well actually. The output waveform, as you can see on the scope, is nice and clean and looks like perfectly sinusoidal to me. I'm just running through the selection now, just to see how accurate it is. If I turn it to the 1.6 to 3 megahertz range, that's there. So if we turn it to 1.6 to 3, sorry, I got distracted by something in the scope just then, 2 megahertz, and that's what the scope says, 1.978. Let's turn the scope intensity up slightly so you can see it. So yeah, that's good. And if you look at the waveform, it's actually quite a reasonable output. It's that's 2 volts per division, so that's 2, 4, 6, 8, 10. That's 12, nearly 12 volts peak to peak at its maximum amplitude. So quite a high output. Let's try on a lower range. So what's that? That's 350 kilohertz to 750 kilohertz. So let's try that at 400 kilohertz. Bring the time base down slightly. Pretty good. Let's just have a look to make sure I've got it spot on. It's got a nice controlled dial here. It has got a vernier adjustment. It's a fairly coarse vernier, but it does actually does give a very sort of controlled, nicely damped control to it. So yeah, 392 kilohertz. I've actually got the cover off it at the moment, so of course that might come in a bit further when I've got the cover on, the extra capacitance, so the cover might bring it in spec, I don't know. You have a look inside, it uses a couple of shielded tubes in here, or valves in here. We'll look in here so you can see, really absolutely solidly locked. I can't even pull these off, certainly not one-handed. It's that 4-gang tuning capacitor. A couple of electrolytic cans down here. That's the main transformer. Obviously all the oscillator and switching parts for the attenuator. That's the attenuator switch. There. This is your variable attenuator here. You can see all the tank circuits for the oscillator here. And it looks like some sort of serious filtering and sort of some work's gone into this to make it a very stable output. There's 11 volt reference pot there by the looks of it, obviously part of the power supply system. Really nicely made. Obviously one of Tektronix's early bits of equipment, probably when the old D52 scopes were around, the D50 or the D range, the S and the D range, which are the valve oscilloscopes that were very popular in the late 60s. It's got this very strange connector. It's like one of the large TV connectors we used to have in this country, but it's a much larger version. I don't know what they call these, but I might modify that to fit a PL259 on there. I won't turn it over at the moment because I've got those mini grabbers on the back, but if I turn the power off, you can see at the bottom there's a capacitor with that's a date code on the bottom, so you can see a date code on there, but it looks like it's possibly 1966, which ties up fairly well. It's actually an interesting note there. It is desirable that only silver beaded solder be used on the ceramic terminals, and for thinning the iron, ordinary tin leaded solder may be used, but repeated used will break the solder. What? To cement bonds, see instructions manual. I don't know what that's about. That's obviously to do with some of the soldering connections inside the unit. So let's have actually one of these sort of like these later RF connectors you find in the sort of like the 70s and 80s stuff. These snap-on connectors. It's beautifully made actually. It's an actual work of art inside. If you see the quality of the soldering's really very good. It's all nicely laid out, and these strange sort of like ceramic tag strips, which I've never seen before actually. You see obviously some silicon dies there. That's nice. Caution, transistor case elevated. That's a nice warning. Obviously it's a fair potential. So that's the power, obviously the power supply section, and that's the other side with all the resistors and things. And it does look actually as some of these resistors, not so much those, but these look like some sort of high precision resistors. If the camera's going to focus, come on, look like some sort of seriously high precision resistors. So be interesting to see how reliable this thing becomes, and might be useful for making a marker signal on when I'm using one of the other generators. I'll be collecting quite a few signal generators now. It's becoming a bit of an obsession. But as this was free, and it seems a nice bit of kit. It seems such a shame to just send it to the scrap pile. I'll see how it goes. See if it's any use, and if it is, I'll carry on using it. Quick run down the front panel. You've got the frequency range. What's this 50 cycle only? I don't know what that is. I don't think that actually outputs a 50 cycle waveform, where it means the input is only allowed to be 50 cycles. Let's power it up and just see if that produces a 50 Hertz waveform. I assume it. Can't believe it would output a 50 Hertz waveform, to be honest with you, but maybe it does. This is your coarse attenuator adjustment. You got the reference attenuator, and then you've got the calibration point where you turn it fully anti-clockwise, and it will give you obviously a referenced voltage output. Let's click this up and see if we've got anything on the scope. Okay, we've got something on the scope. Okay. Trying to get these connectors to stay on. I must change this first. Okay. Sorry, the background noise of the rain. No, that's interesting. It says 48 kilohertz. So I don't know what all that 50. Yeah, the output is 48.38 kilohertz, and yet that's 50. Misread that. I thought I read that as 50 hertz, but that says 50 kilohertz only. So that could possibly, I suppose, be its internal reference, which is slightly else. But I'm not too worried about that. You know, as long as I know the output on the scope, it'll be fine. So yes, interesting bit of kit. Hope you found this interesting, and thanks for watching.